Hi, everybody, and welcome back to yet another cracking installment of the Matt Brown Show. This is the Built-in Colorado show because it's so rad here. Can't stop saying that. Anyway, but I digress. Today, I'm connecting you to an amazing founder and team really doing incredible things for the human race when it comes to space debris. And his name is Gary. He's co-founder of CisLunar. Welcome to the show, bud.
Thanks, Matt. Thanks for having me on here. Appreciate it.
Cool, mate. Just lift your camera for me somewhat, just so at your top of your head, I can get your pretty face. There you go. See, now everyone's with us. Cool, buddy. So thanks for being here. It's great to have you on the second final show of the year. But for our viewers around the world, Gary, who haven't heard of the amazing things that you are doing as a team, why don't you give us a little bit about your background and give us the elevator pitch to CisLunar?
Sure, yeah. So my background is coming from kind of outside the space industry, and that's what we're involved in right now. I come from a background of entrepreneurship and finance, sort of an amateur engineer, I guess, if you will, a bit of an inventor. But I've always had a passion for space, and as I was going through my finance career, doing budgeting and financial analysis for large and medium-sized companies, I was watching the space industry kind of develop and become much more entrepreneurial and open to not just governments and large defense contractors. And I wanted to get in. I've always been fascinated with space. I mean, my earliest memory of space stuff, I had I must have been like 12 or so, made taped together pieces of graph paper and drew out a big lunar base map that I thought I wanted to help build someday. So yeah, it's always been in my heart. And then I went to the International Space University as my way of getting involved in the space industry. And when I went there, I was director of finance at a SaaS software company here in Denver, and about $200 million in revenue size company. Quit my job there and went to the International Space University in Cork, Ireland, where I met my co-founders. And I went there with the intention to find some co-founders who wanted to get on this crazy adventure and go build a space company that was going to, push the envelope of humanity going into space. And that's how we got started.
Cool, buddy. So let's see here.
And I guess CisLunar Industries, I didn't tell you about what CisLunar Industries does yet, but
Yeah, I was gonna. Well, that's fine. That's fine. So it's pretty hardcore what you got, or at least from my experience. I'm gonna show you some cool videos. By the way, guys, if you are catching just the audio, head on over to YouTube and subscribe because there's some cool stuff we're showing you on every episode. So Gary, what is CisLunar trying to do here around space debris?
Yeah, so really at its core, space debris is one of the key pieces of it, but we are trying to build what we see as the steel mills and the aluminum smelters of the next industrial revolution, which we see happening in space. So it's actually much bigger than just space debris. What we're creating is a capability for processing metal in space to be used in space to help build this industrial economy. If you think back to the last industrial revolution at the beginning of the 20th century, it was people like Andrew Carnegie that built the steel mills that helped to create that capability for sort of underpins all the modern economy today. And we think it's going to be just as critical for space as we go out there and move sustainably beyond Earth. And what's great about it is, as we were investigating this idea at the Space University, I became more aware of space debris and the problem that space debris poses, and realized that, okay, we've got all this material out there, it's already refined, somebody's got to deal with it anyway. This could be the first feedstock for these steel mills of the future to process and utilize, and we really kill two birds with one stone. We're able to accelerate the development of this technology, create a source of materials for manufacturing companies who want to build stuff in space, and also build this foundational capability, which we can then use to process lunar material and asteroid material and all other sources of metals as we move out into the solar system.
So I was just checking out your kind of vision here. So when you say process and provide critical metal materials, what are they?
I mean, so when you think about the value chain for developing resources in space, and I guess I should back up a step. If you're going to take humanity off beyond Earth, like say to the moon or even further out, and you want to stay there on a permanent basis, you're not bringing the stuff with you from Earth all the time, right? So it's really key to develop this capability of using the resources where you find them and be able to whether that's like oxygen and water for just living or making other things, or if it's for constructing equipment and housing and bases and that sort of thing. So the critical metals that we're talking about are just basic metals on Earth, things like aluminum, iron, steel, that kind of stuff that here is seems like kind of basic and inexpensive. These things are hard to come by in space. We're bringing everything up with us right now, so we're trying to solve that piece of the puzzle. If you're going to have an industrial economy, and you want to take things that are mined from one end of the value chain and turn them into something that manufacturers can use at the other end, somebody's got to process those mined materials into that intermediate product that the manufacturers can use.
Hmm. So, what's the well, given everything you've said, what would you say is the market opportunity for this? Because you know what I mean? Like, it's kind of out there, bro. No pun, well, pun intended.
Yeah, of course. Like the long range vision is out there, right? It's a long ways off, and I mean this is hundreds of billions of dollars kind of market opportunity when you get into this future state. But of course, that is when that happens is obviously debatable. It could be in the next decade. It could be a few decades from now, but it is coming. And the key pieces to make this happen, while it might sound like science fiction, and it does to a lot of people who aren't like deep in this stuff, it's already being built. Like there's companies that are doing in-space manufacturing right now on the space station. There's several companies that have raised a ton of money to build private space stations. There's companies that are doing in-space transportation. All these pieces of the puzzle we need. There's a company in Australia that we partner with quite closely that can use metal rods like this one, which we manufacture, as propellant as rocket fuel, if you will, not to burn it, but to use it in a different way to move things around in space. And so the market opportunity we think is absolutely massive. I mean, if you look at the market opportunity for building steel mills, at the turn of the last century, it's huge, right? In the near term, to get there is obviously a more, it could be a longer path. We have a way of getting there right now that we see ahead of us. We're planning for first commercial operations on the space station in 2025. And then that could grow pretty quickly by the end of the decade to a multi-$100 million business already by itself.
Hmm. And you guys are working with NASA. You've been heavily featured in the media, and. Walk me through your relationship with NASA, because when I think about SpaceX, for instance, it's like they outsource a lot of their payload delivery into orbit to SpaceX,
Yep.
just because they do the best job at it. So
Yep.
what is your relationship with NASA, and what are you doing with them?
Yeah, so we started our relationship with NASA in 2020. They put a sort of during the pandemic. They do this every year, but they kind of accelerated the process then. What's called a SBIR, or Small Business Innovation Research contract. Sometimes it's a grant, sometimes it's a contract. With NASA, it's a contract. And you make a proposal to them they put out things that they need, a whole variety of things. And that year, they happened to put out a call for recycling metal outside of the space station, scavenged from large objects. And it just so happens that we had been talking about this when we were trying to get this set up in Luxembourg for at least a couple of years prior to that. And NASA, had not previously put that much attention on this sort of thing, but it became a part of this offering, and we went for it as a U.S. company. Any U.S. owned company can go for these things, and they gave us the award in 2020 to build to take our idea from concept to what we made as our first prototype, which was really exceeding the expectations of NASA. Because of that, we were able to develop the relationships there and get our phase two. So phase one is $125,000. I think it's a little bit higher now, but that's what it was back then. Phase two is $750,000, and that's taking for 2 years to develop this technology to something that could actually go up into space. And so that's what we're doing right now.
So let's talk about, well, before we get into what you have actually built, because I want to again show everyone some cool stuff video wise. How much space debris is there? You know what I mean? Because
Yeah,
like
yeah.
I hear about like you know I think Elon's launching that global satellite network, and they're putting thousands and of satellites into space in one payload. It's like it's like thousands. It's like a lot. What sounds like a lot. And then the rational part of my mind's like, well, how much stuff are we putting up there versus
Mm-hmm.
bringing it down? You know
Mm-hmm.
what I mean? Because
Yep.
it's like how big is just the space debris problem at the moment?
Yeah, I think the current last count I saw for active satellites was something around 4,000, 4 or 5,000 satellites in orbit right now. A good chunk of those are the 2,000 satellites that have been launched for the Starlink constellation, which is what you're talking about, that SpaceX has put up there. They have plans to go as big as 40,000 satellites in that constellation. I think their current license is for 12,000, so they're still building up that constellation, but it's definitely the most developed so far of all the constellations. There are several other constellations that are planned, but in total, there's satellites that are operational. There's old upper stages from rockets because it used to be when you launch a rocket, you have the first part gets you up so far, it doesn't make orbit, it falls back to Earth. The next part, might get into orbit, and that part just used to stay up there. Now we don't do that. Now we take that part back down, let it burn up in the atmosphere. Or in SpaceX's case, we reuse the first stage, and the second stage burns up in the atmosphere. And so there's a whole bunch of upper stages up there, which we think are probably one of the easier things to target from a resource perspective if we're going to recycle them because they're mostly metal. They're kind of more uniformly shaped and that sort of thing. And then you got a whole bunch of old dead satellites too. So you have a whole bunch of different orbits around low Earth orbit, which is where the space station is. Where Starlink constellation is. Then you have less number, but still quite a lot in what's called the geo orbit, which is where your sort of direct TV satellite comes from and that sort of thing. That's a bit further out. And those satellites, when they're done with their end of life, they you can't bring them back. It's too far to come back. So they just go out a little further in what's called the graveyard orbit. And even in the graveyard orbit, they're not perfectly stable there. So there's I think the last count I saw was something like 10 million kilograms of material amongst all this, these old satellites and active satellites all put together. I think that was the last number I saw on that. So a good chunk of those we think we can go after, with our partners. We're not going after them, by the way. I should make that clear. We're just building the steel mills to process them.
Mm.
What we're doing is partner with companies that can go out and get these things and bring them to us.
So I never hadn't even heard about a graveyard orbit before. So this is literally an orbit for junk in space.
Pretty much, yeah.
Huh.
When your geosynchronous satellites are 36,000 kilometers from Earth. When they go to the graveyard orbit, they use a little bit of what fuel is left, and it pushes them out to about 300 kilometers further. So they're not that much further away, relatively speaking. By comparison, the space station is 400 kilometers or so above the Earth. So when we're talking about low Earth orbit and geosynchronous orbit, there's a pretty big difference in distance.
Mm-hmm. And what happens when is it possible or feasible to run out of that orbital space?
Yeah, I mean, this is a concern of many different people in the space industry. There's a lot of international agencies as well as companies working on trying to solve the space debris problem. There is a kind of a carrying capacity of these orbits. If they get too crowded, things will start to run into each other. And there's this thing called the Kessler effect that was theorized back in the 70s, where if it gets too crowded, you have too many collisions. Collisions cause more collisions, cause more collisions. You have this runaway effect where you have kind of a cloud of debris that makes it really hard to use any of the orbits we need for space. And if that happens, then we're all going to be in a world of hurt because we use space a lot more than people usually realize.
Yeah, exactly. Well, this is why startups like yours are so valuable. So, let's talk about what have you built. So, what exactly have you built? So, how do you take like these satellites units,
Mm-hmm.
whatever the stage is, and recycle the damn thing in space? like, like interesting challenge.
It is an interesting challenge indeed. So the way we envision this happening is we have what we're calling the space foundry. This is our core technology. So what this is a machine that can melt down metal and process it into different shapes. And it uses what's called a continuous casting process, which just means that we can, as we keep feeding material into it, it can keep making longer and longer things, which can be useful for certain applications. And then we partner with companies that can host that foundry on, say, a space station. And there's a number of companies that are proposing to have these space stations. Most of them want to have this capability on board. And then we partner with other companies, like there's another one that's a Japanese company that also has a U.S. headquarters here in Denver called Astroscale, and they make what would be like the tow trucks of space. So they would send out spacecraft to go grab these things. And the way the process would work is Astroscale would go out, or other companies as well, grab these objects with robotic arms, basically, move the object back to a platform, and then it would get docked onto that platform or a space station, and then another robot would come and start cutting pieces of that off. And so what I think is going to happen is there's other companies that want to build these sort of large volumes, spherical volumes and other shapes. So what I'd like to see is one of those used to kind of be the garage to take these things apart in. So we stick the old upper stage inside this large volume, and then another robot comes and starts cutting pieces off of it. And we might, if we're going to recycle the whole spacecraft, we're going to want to separate, say, the aluminum from the copper wires and from the steel rivets and the coatings and so much. We don't want to have all these things hodgepodgey together for construction materials. But then once we've done that, we'll cut strips of it, and those strips will get fed into the furnace, where they get melted down just like they do in any sort of metal furnace. We make our part. We either make fuel rods to go, fuel the retrieval of more debris, or we make something like wire or, tubes or sheet metal that we then sell to other customers who want to make either space stations or other satellites in space.
Pretty hardcore. Yeah, like that's definitely not on my window of or on my roadmap, which I guess is a good point of departure for the question which I have for you. Which is on your roadmap. What is actually on your roadmap, and what does your technology readiness level look like for NASA?
Yeah, so right now, I think from NASA's point of view, out of our phase one, we were a TRL 3 plus, so not quite a TRL 4, but now we've flown in a parabolic flight. So in our phase two, the intention is to get that all the way to the point where, with some additional funding that we're going to be applying for, to where we can take it up to the space station and do our first demo. And so, right now we're 6 months in. We did a parabolic flight just a few weeks ago, and there we were able to show, how two of these key subsystems that will fit together to make the furnace one day can work in that first try at microgravity. And it worked pretty well. So I would say, at this point, we're, at least at TRL 4, heading into TRL 5, depending on which piece you're talking about. Then our roadmap is to do a full demonstration in 2024 on the space station in the Bishop airlock, which is a privately owned airlock run by NanoRacks on the space station, with our partners at Axiom Space, who are putting the first private module on the space station. And that leads us, if that works the way we want it to, that leads us directly to that first commercial unit in 2025 on the Axiom module, hopefully, because that's when they want to have their commercial module up there, to do on-demand metal processing, where we would take, in this initial case, we'd take scrap aluminum that's inside the space station already from experiments that would otherwise you have to pay for them to be sent down. Instead of sending them down, or the scrap part anyway, we would process that into, say, wire for 3D printing. Axiom has customers in mind for that. We create a nice little economy in space, and it grows from there.
How do you commercialize something like this? Like it's way out of my wheelhouse. So,
but that's how I just told you.
Yeah, so no, but put numbers on that.
Well, if you'll put some numbers on it when we talk about this first opportunity. There is a certain amount of mass that is sent back down because of supply constraints for sending things back down from the space station to Earth. And I guess maybe back up one step there. When somebody sends an experiment up to the space station, it has a certain amount of material on it that's necessary to survive launching it there, because that's a very violent, experience, right? Not all of that is necessarily needed to bring back for science reasons. So we take some of that off. What we've estimated is with just 1 to 2% of that mass that would otherwise be sent back down, converted into materials that we can then recycle, we can already generate, $1 to $2 million in revenues. And that's just a starting point for a space thing, but it's a beachhead. And then as we grow this opportunity, when customers start to realize that they can, instead of sending things down that they don't need, recycle it on station for less money, they'll start designing their payloads to have more of it recyclable. We start designing for that capability. And then we expand to multiple space stations in low Earth orbit, which we think, depending on how things go, there could easily be 5 by the end of the decade. This grows, as you do some of the numbers there, it grows to $100 million business, just from that part of the opportunity set.
Mm. Yeah, and then you can challenge the Klingons for interstellar domination, right?
You're talking to a guy in the government recently, and he's like, "Yeah, you guys are basically building the technology to build the Death Star." It's like, okay, that's not the intention. The idea is to make large scale things, though.
Yeah, exactly. Have you watched, just side notes? Have you watched that Death Star canteen clip?
I don't know. I have to look at that.
Eddie Izzard, the Death
I don't
Star
think so.
canteen. He's a comedian.
Oh no, I don't think so.
I was like, oh, there must have been a Death Star canteen. And then he does this whole
Right.
thing. It's the funniest thing for everyone. Just go and take a look. I got it up on screen for everyone. It's on YouTube. Just search the Death Star canteen, or it'll put a smile on your face for sure.
Yeah, definitely.
So, Gary, how do you raise money for something like with what you're doing? I'm curious to get what your experience has been.
Yeah, I mean, so far we have raised a pre-seed round that was $665,000, and then we got funding from NASA, and then we got funding from the state of Colorado as well. So altogether, it's 1.84 million that we've got lined up from private investors and government sources to start with. And as we've been approaching the market, for subsequent opportunities, it's challenging because you have this long range vision, right? So I think part of it is in the beginning it was angel investors that came in, friends and family, and also more professional angel investors. But to get the VCs, you have to find funds that are sort of aligned with this deep tech vision that can see the long range view. And we have some investors who are potentially lined up, who might want to jump in on this as the round comes together. But really, the ones that are interested so far, they already have a vision for space. They see this future industrialization happening already, and they're willing to tolerate the uncertainty around the market timing for this sort of thing. It's not going to be ideally suited for investors that want to turn something over in 5 years, if they want to get that quick ROI, because it's just not that kind of investment. This is more akin to like biotech or developing a mine that's out in the wilderness somewhere because the resources are so valuable. And it's you got to be comfortable with that kind of early stage risk.
Have you thought about?
Oh, sorry, go ahead.
No, I was going to say, have you thought about approaching Elon?
We've thought about it. In general, we've not yet is the answer there, because SpaceX tends to be pretty vertically integrated. Our whole approach to this market is much more broad-based collaborative, much more like what you see in the economy on the ground. Is what we envision happening in space, where people aren't you don't have these monopolies that are vertically integrated across the whole thing. You have people that specialize in platforms. You have people that specialize in transportation. You have people that specialize in foundries. Like, this is, I think, how it's going to unfold ultimately as the economy develops. But we haven't really approached SpaceX yet about this. We do see them as a potential customer someday to reprocess that constellation of satellites instead of burning it up in the atmosphere, which is what the current plan is. And there's a number of other companies like that out there.
So on the timing point that you made, are you early? Or like, why does the timing? Because if you talk to me about space debris, it's like timing's now.
Oh yeah, space debris timing is now. The part that's, who knows if we're early or not, right? But we are on the leading edge of this thing, and the edge that we're on the part that we're on the leading edge of is the industrialization of space. What they call, the White House just released a policy around this. It's called the ISAM strategy, which stands for in space servicing, assembly, and manufacturing. So this is what they're thinking of as, this is how we want to do missions in the future. We don't want to have to launch everything at once, have it live for 20 years. You can be much more nimble if you you can repair things, or you can build things, or you can change it as you want to go. And if you want to build really big things, you have to build it in space. And if we want to build bases on the moon, we're going to have to build a lot of that stuff there. Not in the beginning, but we will eventually. And so that part of it is definitely early, but it's getting a lot of recognition from the government as a high priority, both on the civil side and in the government side. We have geopolitical rivalries that, China has articulated their intention to go to the moon and develop what they think of as a $10 trillion CisLunar economy by 2040. I think it's 2040. And so, we're right where we need to be. If you want to be competitive in this future, we have to be developing the technology now. And so this is the time to develop this metal processing capability. The part that's tricky is when we talk to investors, we think about the payoff. When are the commercial customers going to be there to take advantage of these materials we're making? It's not so much about the debris, like getting the debris and processing it. That part of it's kind of easy to conceptualize. But what we're trying to do is take something that is otherwise like a Superfund cleanup operation, cleaning up a trash site, and turn it into a mine, basically. So it's economically self-sustaining, where we will go get it because it's valuable. And it's only valuable if you can transform it into something people can use. That's where we come in. But the people who are going to use it is the big unknown timing piece of the puzzle. If that's all going to play out the way we think it will. So the way we deal with it is we have a stepwise way of getting there. If you think about the whole value chain, there's a lot of dependencies and a lot of different companies, and that creates other uncertainties. But if we're only dependent on one at a time, and they can come in as they come in, and we can find places to market our technology as we go, then it works out okay. It just doesn't work for all investors.
Yeah, well, it's funny because I've been kind of thinking about certain types of startups, like yours, for instance, and how there's a doctrine where to fund your startup, you must go to the private investor market. And yeah, okay, cool. But like you said, getting an investor to go, yeah, cool, for you, specifically you, with what you're doing, it may not be for everyone, and it's probably not for most people, for most
Oh yeah,
investors.
it's not for most investors. No.
No. So what's interesting, and my point is Gary, is that I'm finding that a lot of startups are actually using strategic partners to fund their businesses. So going to NASA and saying, "Hey, you come in for the long term, and we'll work with you," or SpaceX, or another space economy focused partner, because they're in the space. They don't need
Yep.
convincing. They're already doing what they're doing, and you can accelerate and help them save costs, make money, whatever the case might be. So, have you explored the strategic partnership investment strategy, and what have you learned if you have pursued it?
Yeah, so we are exploring that, and there are a number of strategic corporate venture capital arms that are out there that we think could be a really good fit for this, and we're talking to many of them that would be already, ongoing talks. Right. One thing I can say is that we have signed an MOU with Sierra Space. Sierra Space is a space company, space focused company. They build a space plane, they build a space station. They're partnered with Blue Origin to build the orbital reef. They raised $1.4 billion in a Series A, to do this, spin out from what was Sierra Nevada Corp, for just space stuff. And they have a fund, and we're starting to talk to those guys as well. But the MOU is around, they want to have our technology on board their space station. And so they're going to help us develop the subsystems and test them in orbit and give us opportunities to do that, and also flesh out the market side of how it would be used as we go forward. I think that's the strategic capital is definitely a key piece of our strategy. There's also other angles too, which is not just space companies, but eventually some of the industrial companies on Earth who are doing metal processing are going to want to get into that market because it's going to be bigger than the Earth market eventually. And they're not doing it now because it's too far out in the future. It's not really on their radar. But they might be great, candidates for strategic partnerships as well, like an Alcoa or U.S. Steel, or any of these other large, metal manufacturers around the world could be good partners for this, so they can get their foot in the door, through us, and start to develop that possibility.
You should check out Founders Fund. It's run by Peter Thiel.
Oh yeah.
And yeah, but he's obviously sold his shares in Facebook and created the Founders Fund. And in there, I highly recommend everyone to read the manifesto, because he breaks down like the problem with venture capital, as he sees it. I've got it up on screen for everyone. See, you got to go to the YouTube channel, people. But he makes some good points around, like, what happened to venture capital. If you have people solving, like yourselves, solving hard science problems, like the traditional venture capital, approach to investing, according to his point of view anyway, is broken, and hence why that's the premise for the Founders Fund. So, and then he breaks down like aerospace, biotechnology, AI, energy, internet, IoT, essentially, and so forth. And in the aerospace sector, he talks about like the barriers to innovation in that space. But from a venture capital perspective, aerospace is huge. Like the upsides are enormous. They're enormous. And so check out Founders Fund, guys, if you want a perspective on venture capital as a startup founder. So Gary, I want to have a bit of fun with you. So obviously what you're doing is a hard thing, and this isn't your first startup. You have also had a startup that didn't survive, but you're obviously taking lessons from that failure and kind of applying them to this venture. What was that startup that died, and what did you learn from it?
Yeah, so that was a startup I founded right out of college in my senior year at University of Colorado in Boulder. It was called Night Riders, and what we did is we drove people home in their own cars when they had too much to drink. So we were like a designated driver service. But this was 2001. So this was well before smartphones. This was before Uber or any of that stuff was even possible. And we were doing it very much the traditional sort of dispatch method. But the unique thing about this company, this startup that I think sticks in people's heads is the motorcycles we used to go out to the customer. So we had these mini motorcycles, and we would ride them to the customer by ourselves. When we get to the customer, we'd take the motorcycle apart. It fit into 4 different bags, and we'd stick it in the trunk of the car. Then we drive the person home. They'd have their car at home when they woke up in the morning. Wouldn't have to go back downtown to get it. They got home safely, and we would just take that we put the bike back together and ride off to the next customer. That was the basic idea. Many lessons learned from that. I was young, had nothing to lose, like literally nothing to lose. My credit was already terrible, so I really had nothing to lose, and except some time, which was fine. And we went for it. We raised a little bit of, angel money as we started to build the idea up, but it was really scrappy, organic growth, building it up, and never quite got to a profitable position. But after running it for 4 years, we were able to get to a point where we had 40 odd employees on the really big nights, like, St. Patrick's Day or New Year's Eve, that sort of thing. We got a lot of people home. The real big challenge on that one was that your demand cycle was like this, because you had this real big spike right at the end of bar close from 11 to 2:30 in the morning, and not so much anywhere else. And the way we had set it up, because we wanted to control how people dressed and what they did and when they came to work and all that, is they were all employees. And so people don't want to work, 2-hour shifts, generally speaking. We would employ them for longer. So it's a mismatch on revenues, capacity and demand. And we tried lots of different strategies for, expanding the demand cycle for this and sort of matching that up a bit better, doing things during the day and all kinds of things. But at the end of the day, despite a lot of support from like the local Coors Brewing Company, for example, sponsored us, and all the bars and everybody was very happy to support us. Media loved having us on for any drinking holiday because we were, helping to solve that problem. It just was too difficult of a business to do. And I think if it had gone long enough, like I wouldn't go back into it now, even if I, knew what I know now, because sooner or later, sending drivers out at night on motorcycles to ride around with a bunch of drunk people was going to result in some kind of terrible accident. So I was like, that never happened, fortunately. But it was quite an adventure. I tied up my entire identity into that company, and so one of the big lessons out of that one was, how to not do that, because there was no plan B. It was just, we're going to do this and it's going to win, and there's just no other alternatives. And we put everything we had into it. And when it finally did fall apart, and it was like, I mean, it fell apart in the way that because there was no plan B, we didn't stop until people started turning things off on us, like turn the lights off and lock the padlock on the warehouse, and then it was over. And yeah, there was a bit of an emotional struggle to try to get past that and figure out, like, okay, now what am I going to do?
Mm.
How do I separate my identity from that failure and move on to the next thing? And so it, took some time, like going to the corporate world and sort of rebuilding my credit and my money resources and career and confidence to go back out there and do it all over again. But it has always been in my blood, though, and that was my first,
Yeah.
you know.
But it's a very powerful story and lesson, because I had that exact same issue, the exact same. So I've spoken about, like, I've founded 14 startups,
Mm-hmm.
25 years, had a couple of exits, massive failure, kind of like what you had. And I sold my first company. It was a record label. I was 26 and I thought I could walk on water. I was like, yeah,
Yeah.
yeah. And then my second business was about personal development. So how do you achieve things in your life, whatever. And the issue I had was that business failed. The universe is going to fix a whole bunch of my ego for me. But to your point, my identity was wrapped up in that business. Oh my fuck. Can I just tell you, when you say that you just scratched the surface, like, I think that and I find it's because you were young and I was young, you know and I think about those days, and I wonder, like, if I just had someone to go, hey, Matt, it's okay, bro.
Yeah, really. That's
Yeah,
yeah.
like it's okay,
Somebody
man.
you would believe too, because it can't just be anybody telling you. People told me that, but
Yeah, yeah. But it's like a dad or a mentor or older brother or another. I don't give a fuck. I didn't have that guy. I didn't have that girl. I didn't have that person to go, yo, Matt, this is the reality, bro. Like, this is how it goes, dude. And by the way, you're gonna have another
right.
9 fail on you, so get used to it.
Yeah,
You know what I mean?
get comfortable with it, right?
And but the thing is, you're like, oh shit, it failed, so I'm a failure.
Yeah, right.
And there's a big so I got another story to share. So my mentor, he owns hundreds of businesses, and like stupid money. And he basically, his first business was backed by an investor. It was like a bagel shop, New York Bagel or whatever, and basically everyone was like, dude, it's gonna die, it's not gonna work, it's done. And he was like, it's gonna work, like, there's no plan B, we're gonna make this work, or it's not gonna work. And then so it died, and so he had coffee with his investor, and he was sat down in front of him. He says, listen, mate, like, I know I'm young. But if it's the last thing I do, I'll pay you back every cent. And he got up from the table and he left. And the investor,
Your
like,
investor left or your
no,
mentor?
no, 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 like my mentor.
Okay.
And the investor, like, slammed his hand on the table and he said, sit down. And it's like, and he goes, so did you fail or did the business fail? And he said, cool, the business failed. He says, good, yeah, exactly. He says, did I back you or did I back the business? He goes, no, you backed me. He says, cool, so you haven't failed. He said, if you walk out of here and you leave, then you failed. But if you recognize that when a business dies, it's not you. It's not you. Like, your identity is not that. Like, businesses die, bro.
Right.
Like, you start another one the next day and rebuild your credit, whatever. That's just the consequence of it. But it's not you. And fuck, I wish I had someone who just told me that, dude. Like, hey, man, it's not you. It's just the business.
Yep, yep. Just to try to, like, there's such a pile of shame you can layer on yourself if you marry the identity and the business together like that. It's a tricky thing to get out of, for sure.
Mm-hmm.
But I mean, I luckily, one thing that is great, the two guys that I founded that company with, we were really good friends going into it. One of them did have good credit going in, and so he was the one who got, like, all these credit cards and loans and things for us to be able to actually pull off some of this bootstrapping. And afterwards, his credit wasn't so great anymore. But you know what? We are all still really excellent friends to this day, because all of us knew that we all went in it honestly. We poured our heart and soul into it. No one took advantage of anyone. And it was hard coming out, but in the end, we did the best we could, honestly. And none of the investors held it against us either, even though I felt like shame around it. In fact, it was really funny. We had all kind of disappeared after it failed. Didn't even go to Boulder. Like I lived in Denver. I didn't go up there, even though I had friends there. I felt like I didn't want to see anyone, you know. And one time, another investor, one of our biggest investors, he had met with one of the co-founders, not me. He's like, "Hey, Carl, you can tell Brad and Gary it's okay to come out now. Like the coast is clear, you know, they don't have to hide out in the woods or whatever they're doing, you know." So
Yeah.
you know, and it was never a problem really, but like I just didn't know how to handle it. I didn't know what to do, you know.
Yeah, and that's also the I suppose the one of the reasons why I do the show, because I hope that someday someone's listening to this and they go, oh shit, and then they remember that,
Yeah.
you know, because then they won't take, which is what I did. It took me, I mean, it's 26, so it took me like 8 years or something like that. It was a long time to get over that.
Yeah, me too. Back on the horse took a long time,
It's
you know.
ridiculous because like now it's like cool, one dies, I'm like literally starting another one. You know what I mean? Like
Right.
at the next day, sort of thing. Because I've recognized that it's not me. It's just a business. Businesses die. Move on. You know.
Yep.
Take
Yep.
the lesson. But cool. So I want to ask you this: if I gave you the keys to the Matt Brown Show time machine, and you could go back to yourself on day one of this business, CisLunar, what advice would you give yourself about building this company?
Hmm. I mean, one thing that is interesting, I think sticking with the original vision and figuring out how to pursue that. I mean, I probably would have moved on from Luxembourg faster. Nothing against those guys; they're great. But recognizing once I realized what their needs were, that we needed to be, you know, somewhere like the United States where we could tap into larger resources of like a NASA. But also this winding path that we went down. We went through an accelerator program at Creative Destruction Lab, which was also a great experience. But we got various different kinds of advice, and because we weren't sure how we were going to get past this crux moment of funding the company, um, you know, we went down some windy paths that oddly enough, even though it has evolved, has turned out to be the same basic concept that we started with in the first place. And having that, like, and this has happened over and over again. Actually, we went through even through Seraphim Space Camp recently. You know, you go through the process, and in the middle of it, I get all this competing advice, and you want to take it all in. And had a really great meeting with Rafferty Jackson, who's part of that program, and lots of other things. And she brought me back to this big vision idea, and I realized that's where we should have been from the very beginning, because that's where the passion comes through. Like when we go back to that true, you know, core reason for doing it, which is the only thing that keeps you going through the hard stuff anyway. It helped to tell the story much more, you know, convincingly than trying to like fit into some formula. So that I think that's probably one of the big things. The other thing I would do tell myself differently. This is other big piece is build stuff sooner. You know, when we started actually building hardware, everything changed. I mean, and bringing Joe on our CTO in 2020 sort of allowed us to start building hardware because he was here in Colorado, I was in Colorado, and man, NASA is so much more willing to fund you if you show them hardware. Like there's a million slide decks out there pushing some grand idea in space or any other deep tech thing, you know. Lots of cool ideas, but not nearly as many who actually execute and build something. Even if it's just like crappy prototype, just start building and iterating. That's the other thing I would do.
That's a very good point. Gary, why do you do what you do?
Yeah, so for me, I had heard years ago um, this idea that I credit to one of the Google founders. I think it's where I heard it, but this idea of like making a dent in the universe and trying to do something that, you know, affects lots of people or that can actually make an impact. And so that I've always wanted to be able to make an impact. And so when I think about what we're doing, why we're doing this one, because there's lots of things you make an impact on. To me, the future optimistic, you know, path for humanity is really only available if we go out into space we take advantage of the resources that are out there, and open up all of that capability for humanity to expand out beyond Earth. The alternative to me is more of a constrained future where we have to find ways to manage the resources that we have and not overuse the carrying capacity of Earth. But I want to have an optimistic future. I want to be able to solve these grand challenges, not me personally, but I want humanity to be able to solve these grand challenges. And my personal belief is that that can only happen if we go out and utilize the opportunities that are out in space. And I want that for my daughter, I want that for myself, and I want that for everyone else. So that's really what drives me forward to do this.
Yeah, I when I when I talk about space startups, something about them, you know, it's like the next level
It
of
is the next
amazing
level of
stuff.
humanity, man.
Yeah, dude. So I'm on your page, man. But listen, it's been a real privilege chatting to you, dude. And I think what you guys are doing is really, really hard, and like that's what makes it valuable. And I believe that your timing is right. And I have no doubt that you'll go on to do great things. So, yeah, thanks for being on the show.
Yeah, appreciate the conversation. A lot of fun.
Anytime. Thanks,
Thanks a lot.
everyone.
Yeah.
Ciao.
Bye.